Hello students, we will discuss now the expression for collector current in active mode. Expression for collector current in active mode. Okay, when BJT is in active mode, when BJT is in active mode, when BJT is in active mode, what is the collector current? Collector current IC is equal to IPC plus IC naught. If you remember this point, we have taken this from this equation, right? That formula was taken over this point. Okay, if you observe in the previous classes how we got this IC is equal to IPC plus IC naught. Okay, you can see in the previous classes from the same channel. And what do you mean by alpha? Alpha is nothing but alpha is the current gain of BJT. Yes or no? What do you mean by alpha? Alpha is equal to IPC divided by IE. That implies, can we write this equation as, let us take this as equation number 1. Can we rewrite this above equation as IPC is equal to alpha times IE? Okay, let us take this as equation number 2. Substituting this 2 in 1, then what we get here? Then IC is equal to alpha times IE plus IC naught. Yes or no? So this is the equation number 3. This equation 3 represents the collector current in terms of IE and IC naught. This equation 3 represents the collector current in terms of IE and IC naught. So symbol of PNP will be, what do you mean by symbol of PNP? If you observe this point, symbol will be if you observe, this is the collector, this is emitter, this is base. For PNP transistor, this arrow is away from the emitter. This is what the PNP transistor is. How the current directions will be? Current direction will be always this way. For PNP transistor, this is IB direction, this will be the emitter current direction, this will be the collector current. Okay, if you draw a circle like this over this now if you treat this transistor, PNP transistor, as a base point, as a single point, node point, then what are the incoming currents from this point? If you see this circle as a node for a PNP transistor, how the currents will be? IE is equal to IB plus IC. Yes or no? Let us take this as equation number 4. Okay. So that will be the equation number 4. Then substituting this equation 4 in equation number 3. So substituting equation 4 in 3, what we get here? The value of IC is equal to what we have there? Alpha times IE plus IC naught, no? alpha into what is the value of IE now? IB plus IC plus IC naught. Yes or no? IC is equal to this value. If you manipulate this, IC minus alpha times IC is equal to alpha times IB. I am multiplying this alpha to inside of the brackets. Alpha into IB plus IC naught. Okay. If I take common this IC as a common factor, then what we get here? 1 minus alpha is equal to alpha into IB plus IC naught. Then I can write this value of IC is equal to alpha upon 1 minus alpha into IB plus 1 upon 1 minus alpha into IC naught. Yes, let us assume the alpha upon 1 minus alpha is what? Beta. Alpha upon 1 minus alpha is what? Beta. And then what we write here, what we can manipulate this point, 1 by alpha by 1 minus alpha is equal to beta means then 1 plus beta is nothing but add 1 on both sides. Let us add 1 on both sides, then 1 plus alpha by 1 minus alpha. Then what we get here? Alpha 1 minus alpha plus alpha upon 1 minus alpha is nothing but 1 plus beta. Then what we can common here? What we can cancel? 1 plus beta is equal to 1 by 1 minus alpha. Then beta is equal to, that is 1 plus beta is equal to what? 1 by 1 minus alpha. 1 plus beta is equal to what? 1 by 1 minus alpha. So we can replace this 1 by 1 minus alpha as 1 plus beta. Can we write like that? So if we manipulate that equations by these substitutions, then collector current will be IC is equal to alpha by 1 minus alpha will be beta times IB plus 1 plus beta times IC naught. This is very simple equations. This is also very important for the exam. So let us take this as equation number 5. Equation number 5. What do you mean by alpha and beta? Alpha is nothing but common base current gain. Alpha is nothing but the common base current gain. Common base current gain. What do you mean by beta? Beta is nothing but the common emitter current gain. Okay, hope you understand this point. Therefore, the relation between alpha and beta is the relation between alpha and beta. Relation between alpha and beta. Beta is equal to alpha upon 1 minus alpha and alpha is equal to beta by 1 plus beta. Okay. Beta is a measure of amplification and ability of a transistor. A transistor will be what? Higher beta can act as a better amplifier. If beta is more, amplification is good. Amplification is better. Okay. you have to also learn some more few more definitions. 2 points here. The point is IC B naught. IC B naught is nothing but it is a collector current when emitter is open circuit. Is a collector current when emitter is open circuit. When emitter is open circuit. Okay, in the same way, IC E naught. IC E naught. IC E naught means it is a collector current. Is a collector current. Is a collector current when base is open circuit. When base is open circuit. That implies for this, how can we write here? IC B naught is equal to IC when emitter current is open circuit. When emitter current is open circuit, that is nothing but IC naught. Okay. In the same way, what do you mean by IC E naught? IC E naught is nothing but is a collector current when base is open circuited. When base is open circuited. That implies 1 plus beta into IC naught. That is nothing but IC naught by 1 minus alpha. Substituting these values of IB equal to 0 and IE is equal to 0 in equation number 5. Okay, substitute these values in equation number 5. Thank you.